back to you by Monday, Tuesday at the very, very latest, but I'll try to get them back to you within a week. All right, I'm going to go ahead and you've probably noticed in your syllabus that I have something due on Monday. So let's go ahead and pull up the syllabus and take a look. I shouldn't have exited out of Chrome. That is what I have learned. Okay. All right, so if we go ahead and open up your syllabus, let's see. Hey, Beth. All right, so if you go ahead and look in your syllabus, you can see that our fourth homework assignment is coming up. I am going to tell you a spooky story today called The War of the Ghosts. And if you are watching on recording, because I know that not everybody can be here today, please make sure that you watch this and return this back to me as much as you can remember by Monday. So here's what I want you to do. Don't try to remember it after class. At the very earliest, try to remember it later tonight at the earliest, but make sure that I get that by Monday, okay? All right, we do not have a quiz this week, so you have a nice little breather. And yeah, that's about it for now. I will be adding your next paper because we're a little bit behind. I am going to add an article about police lineups since we are going to start talking about that next week. Okay, so as promised, I am going to tell you a scary story. So
we don't need to take notes.
No, it's better if you don't take notes. Like, do not take notes. Okay, so to kind of give this the proper ambiance, I am going to turn out the light and I'm going to illuminate my face by a flashlight because it's a spooky story. Okay. All right, let's get that story. Yeah, don't write this down. All right, here comes, that's not the story. Where is it? I gotta find it. Here we go. Okay, let's see. Load up. I need to read it. Okay. Quit. Ew. Okay, I gotta find it. So talk amongst yourselves until I do. Talk amongst yourselves until I find the story. Okay. All right, here we go. All right, let's add a little extra ambience to this. So, like all good creepy stories. Oh, actually, no, that's shining at you. The light from my face will help. Okay, actually, let's make it super bright. There we go. Wow. Okay, the War of the Ghosts. One night, two young men from Egulac went down to the river to hunt seals. And while they were there, it became foggy and calm. Then they heard war cries, and they thought, maybe this is a war party. They escaped to the shore and hid behind a log. Now canoes came up, and they heard the noise of paddles and saw one canoe coming up to them. There were 5 men in the canoe, and they said, what do you think? We wish to take you along. We are going up the river to make war on the people. One of the young men said, I have no arrows. Arrows are in the canoe, they said. I will not go along. I might be killed. My relatives do not know where I have gone, but you, he said, turning to the other, may go with them. So one of the young men went, but the other returned home. And the warriors went on up the river to a town on the other side of Kalama. The people came down to the water and they began to fight, and many were killed. But presently the young man heard one of the warriors say, "Quick, let us go home. That Indian has been hit." Now he thought, "Oh, they are ghosts." He did not feel sick, but they said he had been shot. So the canoes went back to Egulak, and the young man went ashore to his house and made a fire. And he told everybody and said, "Behold, I accompanied the ghosts, and we went to fight. Many of our fellows were killed, and many of those who attacked us were killed. They said I was hit, and I did not feel sick." He told it all, and then he became quiet. When the sun rose, he fell down. Something black came out of his mouth. His face became contorted. The people jumped up and cried. He was dead. Okay. There we go. So your job by Monday is to basically do that story. And Selena, you just came in. I'm recording this. So go back to the first few minutes of class and listen to the recording. I would like you by Monday to recall that story. So for those of you that just heard it, I want you to try to not go back to the recording. Do the best you can with the memory for this that you have. Now that's kind of a weird story. I'm aware that it's a weird story. And what we're going to find is that what you recall will be pretty interesting because this is just a very weird story. So if you're watching this on recording, make sure to listen to the story, and then probably later tonight or tomorrow at the very earliest, try to remember what you can of the story, and that'll be our next homework assignment due on Monday. And we will kind of talk about these because we are beginning a new section today. Hooray! We're not done with memory yet. You may be done with memory, but memory's not done with you. But I think you're really going to like what we talk about today. So I've already put up the notes. So we're going to start today. Oh, did I get rid of it? I think I got rid of it. Oh, goodness. So I uploaded it yesterday, and then I cleaned up my X drive, and I think I accidentally deleted it because I'm just brilliant. So if you will give me just a second, I'll go ahead and pull it up. We are talking about concepts and knowledge today. So while I am getting that set up, I have something that I would like you to do for me. If you want, would you please, if you wish, go to the board, get some chalk. We have quite a bit of chalk up here, it looks like, and I have a chalk stick right here. If you wish, please go ahead and go to the board and draw a dog for me. So if you do that, do that while I'm gone. I will be right back. So go ahead and go to the board, try to draw a dog. Have fun. I'll be right back.
I'm gonna skip this one. Sorry. I'm gonna throw it right here. Gotcha. I'm so bad at art. Oh man. I don't even know. So bad.
Not as bad as mine.
Oh my gosh. This is gonna look like a bunny. Oh man. A bunny? Yeah. Me too.
There's my dog.
Oh gosh. That's crazy. That's a bear.
Inspiration.
Okay. Oh, that's so bad. Okay.
People are actually drawing doggies.
Mine looks like a duck.
I tried to. Okay, I feel really bummed that Emily's not here because Emily, there was something I taught last semester in research methods, and I had to draw a goat, and it looked terrible. Actually, we might talk about it in problem solving. So last year's live stream, I drew a goat, and it was terrible.
I don't know what this is supposed to be.
Huh?
I don't know what this is supposed to be.
I think he's cute. It looks like a dog to me.
Okay, that's good. Hers is the best.
That looks a little foxy.
Yeah.
Oh, it's so teeny. It's so cute. Like that dog could sit on my finger. He's so cute.
We'll just give him the face. Oh, it's also cute.
Oh my gosh,
that's good. Right. This is good.
Mm-hmm.
Attention to detail.
Mm-hmm. All right, so let's go ahead, and for those who are watching, I'm going to stop screen share for a minute. We're going to take a look at some of these doggies. Okay, so here's what I find kind of, it looks like it's kind of like a human face on a dog. But yeah, here's what I find kind of interesting is this doesn't always happen this way, but a lot of your dogs are really similar to each other, and that normally never happens. But let's go ahead and take a look at some of the other dogs we got here. So we got tiny little dog. And I don't think I'm going to be able to reach it that far. So you're just going to have to take my word for it. We've got a lot of other different kinds of dogs here. But, oh, there's some more over there. Okay, we got one with short ears. That one kind of looks like Smedley. Actually, if you want to see really quick, here's how I draw Smedley. I just draw his head. That's Smedley's head. He just has that head shape, and that's all I can do. Okay, so part of the reason that I asked you to draw a dog is because every single one of you has a very different working concept of what a dog is. So I actually find it kind of interesting that a lot of you have very similar looking dogs, because most of the time when you do, I'm just throwing things all over the place today. Whenever I normally ask people to draw dogs, I get dogs of different types. Now, anybody who didn't draw a dog, and it's okay if you didn't, this is not an art contest, but I do know that drawing can sometimes make you kind of put you in a vulnerable position. So is there anybody here who didn't draw a dog, whose idea of a dog doesn't match any of these? No? Okay, so I'm going to come back to this because I think it's interesting that all of your dogs are really similar, and I have a couple of ideas of why. But you're actually going to like this because today we are talking about concepts and knowledge. So we're talking about semantic memory. So when we're talking about what it is to be a dog, how do we categorize something as a dog? We are technically doing semantic memory. So I'm going to talk about a couple of different things. So we're going to talk about the organization of categories and concepts. We're going to talk about prototype theory and exemplar theory. We're going to talk about scripts and schemas. And one of the other things that I will mention when we're talking about concepts, one of the things that I hope you're kind of learning from this class is that cognition is all about trying to simplify the world and make it easier to understand. We by nature like to categorize, we like to simplify, and we like to sort things into boxes. And yeah, it does end up making our world much easier to navigate, but it also runs the risk of us falling prey to stereotypes. So we are going to talk a little bit about stereotyping and kind of what are some things that we can do to kind of counteract that, because some of this is a product of how we think. Okay, so we're going to look at a couple of different models that organize concepts. So if I told you that an apple is a fruit, could you verify that pretty easily? Is an apple a fruit? Okay, is a tomato a fruit? Now, okay, now here there's a big difference between what you know and how you feel. Raise your hand if you know that a tomato is a fruit. Raise your hand if you feel like a tomato should be a fruit. Yeah, nobody puts a tomato in a fruit salad. Raise your hand if you think an olive is a fruit. It actually is. Yeah, no, an olive is a fruit. So are avocados, so are coconuts, and so are certain types of peppers. They're all fruits. But you would never probably put those in a fruit salad. Like if I came to you and I'm like, here's a fruit salad, there's watermelon and there's cantaloupe and there's honeydew and strawberries. And oh yeah, I threw some olives and avocados in there too. You'd chuck it back at me and say, take that fruit salad elsewhere. So we have to talk a little bit about how we organize concepts. Just because we know that an olive is a fruit doesn't necessarily mean that that's how we organize that mentally. Our understanding of categories and concepts are actually pretty fuzzy. So we're going to look at a couple of different models that help us kind of verify, you know, what does it mean to be a fruit? What does it mean to be an animal or a mammal or a piece of furniture? So what is a concept? So a concept is a mental representation of a category of objects. So a dog. So what does it mean to be a dog? And a category is basically a set or a class of objects that belong together. So for example, tables and chairs and desks all fall under the category of furniture. So how do we determine what fits into a particular concept or category? So researchers have basically done this. Now, of course, I can ask you all day long, do you think a tomato is a fruit? Yes or no. But that's not really how a researcher would want to do that. So there's two different ways that we try to do this. The first is with a process known as sentence verification. And so sentence verification kind of works like this. And since I'm on Zoom, I can annotate. So basically, sentence verification kind of works like this. I give you a particular sentence, such as a shark can breathe, and you have to tell me if that sentence is true or false. Can a shark breathe? Yes. And we can also look at something like this. So a shark can breathe. That is a property of all animals. We can also say a shark is a fish, which it is. Now, it turns out, based on what we're doing here, it's going to take you less time to verify that a shark is a fish than it will. It'll actually take you longer to verify that a shark can breathe. But the idea here is we're going to look at how long it takes you to verify these kinds of sentences to see how you are organizing these concepts and categories in your memory. The basic idea is that the longer that something takes for you to verify, the farther apart those concepts likely are. So shark, having a property of an animal such as can breathe, is probably farther apart because it takes longer to verify than a shark is a fish. The other thing that we can do is we can ask people how related two items are. So we can say, is a fire truck related to red? Yes. So we can figure out from those yes and no's how closely these concepts are organized in memory. And so these are the two major ways that researchers have largely done this. Okay. So kind of based on some of the early research, it was determined by Collins and Quillian back in 1969 that these concepts are stored in a hierarchical structure. So they refer to this as a hierarchical network model. So concepts are organized in these hierarchical networks, and these hierarchical networks actually make up a significant portion of your semantic memory. So when you're asked things like world knowledge, history information, and other types of general knowledge, they believed that semantic memory is organized in a hierarchical structure. Now, in this hierarchical structure, and I'm going to once again annotate, so what we're going to see is that the structure kind of looks like this. So we'll usually have connections between two different types of nodes at varying levels of the hierarchy. And I'm going to go ahead and put a heart, because I don't feel like drawing a circle. So each of these are different nodes. So these nodes are basically going to be major concepts. And then branching off of these features, branching off of these nodes are going to be different features or properties that are associated with the concept. So I know that that sounds a little vague. Please don't worry. I'm about to show you one example of a hierarchical network, and we'll kind of spend a bit of time talking about how it works. Okay, is everybody good? Okay. I like how you're always very straightforward, Amy.
Sorry.
Oh, it's okay. Did you change your hair?
No.
Okay, it looks more purple than usual today.
Yeah, I washed it with blue shampoo.
Oh yeah,
Shampoo.
it's cool.
Thank you. I type slow.
Oh, it's okay.
I want to try something different today.
Yeah, the more that it's one of those things, like I never actually took a typing class in school. Did any of you? Okay, a few of you did. Yeah, I didn't. I just basically learned how to do like all of that stuff like as I went. It'll get better with practice. I mean, I had one in 6th grade, but it was or 7th grade, but it was like, look at all the amazing things you can do with Excel. And at the time I was like, I don't care. And now I'm like, I tell all of my research method students, look at the wonderful things you can do with Excel, and most of them don't care. So it's kind of come full circle. It's come full circle. I appreciate it. Okay. So one other thing that I will mention with the hierarchical model is something called the principle of cognitive economy. So the goal here, now let's be clear. If we're looking at different types of fish, such as salmon and tuna and sharks, all of them breathe, move around, eat, and have skin. And they have gills. Those are properties that are for all fish, and in some cases for all animals. You are probably not going to find those properties next to the concept salmon. You're probably going to find them higher up in the hierarchy at a concept like fish or at a concept like animal. So generally what we're going to find is that to avoid redundancy, we are going to store properties to nodes as high up as we possibly can. Now, one other thing I will mention is that the more levels that you have to travel in this hierarchy, the longer that verification times take. And again, I know this sounds really vague. Once we actually look at the figure, it'll make a lot more sense. So here it is. So here is an example, and I'm going to spend a lot of time on this slide. So we have an animal. Now, an animal has the properties of having skin. Yes, all animals have skin. They can move around, they eat, and they breathe. Now, notice that all of those properties are generally common to all animals. As a result, because of the principle of cognitive economy, we are not going to store those properties in bird or in fish, or for any of the animals that are mentioned here, right? All of those things are true for all of these animals, so we're going to store those properties up as high as we can. So then we move down to different types of animals. And one of the things that you're going to notice about this category is we have bird. Bird is pretty specific in that it refers to a certain type of animal, but it's still pretty general. For example, I see a lot of different types of birds on my walks when I go around every day to walk the dog. I don't necessarily know the species of all of those birds. Like I know the pigeons, I know the crows, I even occasionally will see a hawk, but generally I don't know specifically what kind of birds they are, but classifying it as a bird is general enough that it covers all of the members of that concept. So when we talk about bird or fish or dog, we are talking about what is called a basic category. Now, an overarching category that is very broad is what is known as a superordinate category. So this would be like animal. This would be like furniture. This would be like transportation. And then basic levels would be things like car, plane, boat. So you can see that superordinate categories are often very general. Basic level categories have a bit more specificity, but they're still general. And one thing that I will mention, when y'all were kids, you didn't start by calling your dog a golden retriever, or if you saw a dog out in the world, you didn't go, Doberman. You called it a dog. So one of the things that we know is that these basic level categories, when we're children, these are the first things that we learn. We don't really learn superordinate right away. And then when we get more specific, we have what are called our subordinate level categories. We tend to learn those later as we get more experience. So now let's go to our subordinate categories. So of different types of birds here, again, we want specific properties that are only for canaries. They can sing. Yeah, I guess there are other birds that can sing, but whatever. And canaries are yellow. And that's generally true. I know very few other types of birds that are yellow besides canaries. Now, then we have ostriches. Now, here's what's interesting. This is a case where a property of ostrich actually contradicts a property of all birds. So all birds have wings, they can fly, and they have feathers. Ostriches have thin, long legs, are tall, and can't fly. Penguins would probably get you a very similar result. Now, here's what I was talking about in terms of sentence verification. So if I tried to determine if an ostrich has skin, here's how I have to verify that sentence. So I start at my ostrich node. I'm going to have to go up to the level of bird and then go up to the level of animal and then retrieve the property has skin. That takes a really long time. On the other hand, saying that an ostrich is tall will take less time because I'm already starting out here and I'm retrieving the property. So by looking at how long it takes people to verify these different sentences, we get a hierarchical structure that kind of looks like this. Does this make sense? Okay, But hopefully you've noticed something that is a little important here. So according to this model, so I want you to kind of think through this. According to this model, if I ask you, is a canary a bird, verified that a canary is a bird and an ostrich is a bird, what are the predictions of this model?
It would say like they both have wings, they both fly. And then obviously for a bird, it would say, or they both fly, but then they both have feathers, but then you'd have to like read.
Okay,
with the flying.
so I like how you're thinking, but you're actually overthinking it. So according to the hierarchical model, all we have to do, if a canary is a bird, go up one level, it's a bird. And guess what? The model makes the exact same prediction for ostrich as a bird. So according to this model, it will take you the same amount of time to say that a canary is a bird as it does to say that an ostrich is a bird, because you just have to jump up one level in the hierarchy. Now, you are hitting on something, Casey, that I think is really important. Now, the model predicts that this takes the same amount of time. Casey, do you actually think it would take you the same amount of time?
Yeah.
You think it would? Would anybody find a difference? Well, let's work with something a little more, let's work with something different here. So, I'm sorry, I don't want to erase the dogs. Okay, so I'm not gonna. Okay, so let's say that this is our basic category of fruit. Here we have olive, and here we have apple. Now, according to the hierarchical model, it should take you the same amount of time to say that an olive is a fruit than that an apple is a fruit. Do you honestly believe that you are going to get the same verification time for both of these? Exactly. Now, why?
I mean, I didn't think olives were vegetables, but I didn't really know that they were fruit either.
So you would not think, even if you knew that an olive was a fruit, do you think of it as a typical fruit? What sort of things pop into your mind when you think of fruits? Oranges, apples, bananas, maybe a pineapple here or there. But we typically don't think of olives. We don't typically think of coconuts. We don't typically think of avocados. Here's the same sort of process. If you ask most people to name birds, they don't typically start by telling you about ostriches or penguins or even chickens. They start telling you about things like mockingbirds and robins and cardinals. So even though this model predicts that it would take you the same amount of time to say that a canary is a bird as an ostrich is a bird, that's not actually true. Now, before we get to that little point that I was making, I want to talk about those three different category levels that I mentioned: superordinate, basic, and subordinate. Now, as adults, we use all three category types on a regular basis. Roche and colleagues reported in 1976 that the basic level category is the most useful. It's specific enough to differentiate between, for example, different types of animals, but it's not so general that, so it's specific. It has a nice perfect level of being general enough to describe all of the different birds that you see, for example, but not so specific that you can't differentiate a bird from a fish. And as I kind of mentioned, basic levels are typically what we acquire first during development. You don't say animal, and you don't say golden retriever. You say dog or doggy. Now, here's what we do know though, experts. So if we're talking about a bird watcher, or if we're talking about a dog breeder, or somebody who's like an American Kennel Club dog show judge, they're experts. You're going to be more likely to require the specificity of a subordinate level. And by the way, here's something kind of interesting. When we talk about faces, or when I talk about identifying each one of you in class, so knowing the difference between Rebecca and Beth and Jenna and so on, I am actually operating on the subordinate category level. So anytime that I am identifying a specific person or identifying that person's specific face, I am actually operating on the subordinate category level, because the standard level would be person. Look, I got a class full of people, but it's only when I individuate them that I'm operating on the subordinate level. Well, somebody's popular. Somebody buzzed. Okay, so let's talk about one of the major problems with this model. And I'm sorry, I had to share this because it's a penguin. It's the penguin fighting a robin. A robin is a very typical bird. A penguin is a less typical bird. I'm sorry. These are the equivalent of visual jokes for me. One of the things that we do find with the hierarchical model is that oftentimes our verification is confounded or mixed up with familiarity. So oftentimes what we will find when we look at a model like this is that we get faster verification times, not because of levels, but because certain things are more familiar to us. We tend to be very familiar with basic level categories as opposed to superordinate categories. We are more familiar with thinking about birds and fish and people and things like that, as opposed to thinking about animals in the general sense. And so a lot of these findings could actually be familiarity effects. Now, me showing you a penguin and a robin fits with what we call a typicality effect. So I want to go back to our olive and our apple example. Now, according to the hierarchical model, these are both at the subordinate level. For me to get up to the basic level, they would take the same amount of time, according to this model. The problem is, this is not actually what the data shows. An apple is always going to be a more typical fruit than an olive. As a result, it takes you less time to verify that an apple is a fruit than it does to verify that an olive is a fruit. And that's what I was kind of getting at the very beginning when I said, how many of you know a tomato is a fruit versus how many of you actually feel like a tomato is a fruit? You all know that a tomato is a fruit because you've heard it your whole life. I first heard about it when I was 5 years old in a cartoon, oddly enough. But there's a difference between knowing that a tomato is a fruit and actually feeling like it fits in the category. And because of that, despite the fact that it is actually a fruit, most of us would never classify it as one. So what this tells us is that categories are actually pretty fuzzy. People don't typically think of chickens and penguins and ostriches as birds the way that they think that robins are, for example. On the other hand, think about an animal like a platypus. Yeah, I know, right? It lays eggs, but it's a mammal. Lays eggs, but it's a mammal. Like it makes actually, does it lay eggs? I don't actually, does it? Okay, I wanted to make sure I wasn't misinforming you. I'm like, even the fact that I know that it's a mammal, it's hard to wrap my head around the fact that it lays eggs. And in some ways, I'm more inclined to see it as a bird because of that duck bill and the egg laying than a mammal, which is actually what it is. I want to go to Australia and just see all the weird creatures that also might potentially kill me.
Madagascar.
Huh?
Madagascar.
That too.
I just want to see like the giant spiders.
I would prefer not to see the giant spiders. I'm good. Okay. So obviously our hierarchical model does not necessarily work. So the next model that we're going to talk about was developed by Collins and Loftus in 1975. This is a pretty famous model called the spreading activation model. So do you remember when I gave you that list of words and some people reported a false memory? Part of the reason that this happens is because it's based off of the ideas of the spreading activation model. So here we have different nodes. So we have nodes like fire engine, ambulance, truck, car, firehouse. We've got some colors, we've got some fruits, we've got some flowers, we've got some things in the natural environment. So here, we actually have quite a few different categories of concepts here. We have vehicles here, colors here, fruits, flowers, environmental phenomena like clouds and sunsets. So we have all of these different categories, and each of these concepts are organized by semantic relatedness or distance. So when I think of the word red, notice how far away street is. Street typically does not come to mind when we think of red. The same is true for something like house or something like clouds. So the farther away that something is in a spreading activation model, the less related they are. So Collins and Loftus basically developed this kind of a network and this model by asking people two different types of measures of relatedness. They would first ask people, how related are these two words? So for example, bird and canary, those are very well related. Another way that they did this is, what examples of birds can you think of? Now, the idea here behind this model is that when you activate a particular concept by either thinking about it or reading about it, activation starts to spread from the particular node that you activated to anything else that might be attached to that node. Now, here's what this means. So if I activate fire engine, truck is pretty close to fire engine. So as a result, it's going to get a lot of activation. Now compare that to something like clouds, which is pretty far away from fire engine. It might get some activation, but definitely not as much as truck. So you can kind of see why, if I give you a lot of words that are related to a word I never say, why that might be activated and why you might believe that you heard it when you actually didn't. It's because of networks like this one. So when you encounter or think of a concept, that activates a node, and the activation actually spreads to related concepts. So this can explain typicality effects. So for example, so we have different types of vehicles here. Notice that you're more likely to see something like truck, car, and bus be connected to each other than vehicle, even though they are technically types of vehicles. This is a superordinate category, but you're going to get more activation between car, truck, and bus than vehicle will get, because it's a little bit farther away. So this can explain typicality effects. Typicality effects happen because those particular concepts like bird and canary are going to be a lot closer together than bird and penguin. As a result, canary will get more activation than penguin. It also contributes to something known as semantic priming. If I give you the word doctor, for many of you, the next word that you will think of and the first word that might come to mind is nurse. And that's because of your your spreading activation. You probably have doctor and nurse very closely associated with each other in your semantic network. So when I activate doctor, activation spreads to nurse more quickly than it would to other concepts. Kind of cool, huh? So yeah, your semantic memory is kind of made up of stuff like this. So I'm going to end, we're going to talk about one more theory. This is something that was developed by Farah and McClelland back in 1991. This is something called perceptual functional theory. So this is actually kind of interesting. This is a feature-based approach. So we're looking at different types of features of objects. And we actually assume that when we're dealing with living things like birds and plants and fruit, that we're going to focus on its visual or perceptual features. On the other hand, if we are looking at a non-living object, instead of thinking about its physical features, we're going to think about its functional properties. So we actually make a major distinction between living and non-living objects. Now, here's what we know. Most of the time as human beings, we are in contact with more living objects, and living objects are more important to us than non-living objects. I don't care if I hurt the feelings of this remote, it can't ostracize me. On the other hand, if I hurt the feelings of somebody in my social group, the risk of ostracism is great, and we don't want to get involved with that. So what's interesting is we do actually find that in the semantic system, we are far more interested in living things than in non-living things. We actually have more of a focus on visual features than functional properties. Oh, sorry, I got too excited. You know what happens when I get too excited? I rush. It's like in band, can't rush that drumming. I'm like, my fingers don't work that fast. I'm just a tuba. All I do is oompa, oompa.
It's easier on percussion to go that fast.
I'm like, I'm filling 32 feet of metal tubing with my lungs. And now I know why I'm a halfway decent runner at middle age, because I constantly fill my lungs into a metal instrument to make oompa sounds. And that is the functional properties of a tuba, to go oompa, oompa. Okay, one more slide and we'll call it a day, but I'm going to wait for Amy.
Okay.
Oh, wow, that was good timing on my part. Okay, so what evidence do we actually have for this perceptual functional distinction? Turns out that a lot of brain damaged patients actually do experience category specific deficits. And oftentimes what we are going to find is that a lot of people that have brain damage, they often tend to have more problems with living objects than for non-living objects. So this was reported by Martin and Karmaza back in 2003. So there, if you have, we know, and by the way, these are in different areas of the brain. Most of our living object information, hey, look at what areas are involved. The anterior, medial, and inferior temporal regions. Those are the same regions that we talked about with visual object recognition with agnosia. On the other hand, if we're talking about perceptual functional properties for non-living objects, that tends to be in areas like the frontal lobe and the parietal cortex. And that actually makes sense because what's at the back of the frontal lobe? Your motor cortex. What's at the front of your parietal lobe? Your somatosensory cortex, which is all about how to hold things, how to grasp things, and how to move them around. So it actually kind of makes sense that we have this distinction between living and non-living objects, and they are centered in different areas of the brain. Okay, so that is all I have for today. We will talk more about concepts, categories, and stereotypes next time. And we will start our section on everyday memories. So we will talk about your own personal life history and autobiographical memory. And I know some of you were waiting for it. We're going to talk about eyewitness testimony. and like police lineups and stuff. Have a wonderful weekend. Don't forget to return your summary and your memory of the War of the Ghosts story. If you missed it, watch the video. Have a wonderful weekend, everybody. I can't wait to judge your Halloween room.